So we discussed what SAR wavelength is. I told you the different kind of bands, right? These bands.
Mm, yeah,
So invisible, I told you there is just the reference because of our eyes. We know it. We have the names of it. But in SAR, we call it them like
what's a
this.
band?
Yeah. And so each one has its different use case.
Mm,
Um, for example, this Ka band is used for airport surveillance. Uh,
okay,
this Ku is used for satellite altimetry, like for the satellite to know its height from the ground.
oh, okay. So only for that, or
Uh,
it's
not only these are just like one examples of it.
okay.
There can be many. So
Mm-hmm.
for X band, you have they can be used in the satellite or marine radars and weather radar.
Mm-hmm.
There are different kind of examples.
Okay. So I have a question like if we are
Yeah.
using instead of satellite, we are using a drone. Okay.
Yeah.
So I have a requirement to study about the marine things related to that. So I need
About
a
the
sensor. I have a requirement to study or research about any work related to marine. Okay,
okay.
so then what would be the property like object I have to use in my drone? The sensor should have the X band, right?
Oh, it is. We can't like specifically saying that, but like yeah, it is used in marine radar. But since you are saying it to use it on a drone,
Mm.
so I'm not sure if like then in that case we'll be using X band. But for example, uh,
So generically we have the lidar in
yeah, just
in drone we can use.
yeah.
So, okay. So very recently, I was looking for a solution. Like I used to hear there is a for surveillance in forest. Okay, in the night, if there is a thick canopy, correct, in the dense forest, we need to find the animal which things are moving around and to control the poachers.
Mm-hmm.
So that time we'll be having a difficulty on thick canopy like Western Ghats and all.
Yeah.
Which type of sensors we need to use?
Okay. So like for marine also, so it is giving different ex like depending on your use case, it depends what do you
Mhm,
want to use it. Like marine is really wide. So
mhm.
you can use different kind of bands for like particularly the example you just said now. So what we can do is showed you that one.
That calculation we have to do is the calculation.
Yeah. So if your drone is fitted with, for example, You have P band, so you can look for animals like on the ground.
Mm-hmm.
But if you fit your drone with maybe X band, then your drone will be useless in the application. Like you said, you want to see the animals.
Mm-hmm.
Yeah. Uh, you understood that?
Yeah, yeah, I got this, but I'm just asking like whether there is a radar and bands for drone as well, like satellite.
Yes, yes. It is the same sense. It is the same bands for in the satellite or in the drones. Just the thing
Mm.
is, for drones, it would be really costly. You can get all the
Mm.
bands available to you. Like
Okay,
these all are available in drones also.
okay. Mm-hmm.
Yeah. But it is very, you can say expensive or like, uh, it would be difficult to find people who supply the
Mm.
SAR band for like microwave band for the drones.
Okay.
Yeah. So, uh, other than, so they have also explained a classification of hair rate. If you want to see that, now we know that every band has its own wavelength.
Mm.
It's not coming. So, X band, as I know, it's very commonly available. So, in satellites like TerraSAR, Cosmo, SkyMed, PAZ, this is used highly.
Mm.
So there are some of the satellites that are famous one. That is NVSat, European Remote Sensing Satellite 1, 2,
Mm.
Sentinel-1 A and B, Radarsat 1, 2, Elos Pulsar. This is very famous uh, satellite. We use its other products also. This is Cosmos SkyMed is kind of a paid, like you have to pay very high value. TerraSAR X is the most advanced SAR satellite we have. It's by a German space agency. So it has very, very, very high resolution. It is like
Mm.
uh, you could using it if there is a deformation in ground of even 1 centimeter, this
Mm.
satellite can detect it.
Oh, okay.
Yeah. But if you want to have it, like it is very costly.
Mm-hmm. But it captures everything on the earth, like every part of the earth, or it has certain defined like certain area this would cover and it is not covered in certain areas.
So, for example, it depends on the institution has launched the
The
satellite.
purpose.
Yeah. So they could have only they have placed it in the orbit as such that it only covers certain part of the world. Or for example, European Space Agency might uh, have an satellite which only covers Europe only.
Mm.
Because there's a costing involved in each, all of the functional costing is involved. So maybe they are just covering the areas important to them. There are some satellites, for example, Sentinel-1 A and B. That is probably covering the whole Earth, probably. But
Mm.
uh, Sentinel-1, yeah. So it depends on the use case of the satellite, like which institution has released it. Now, this is how a SAR image will look to you.
Mm. Okay.
So this is a normal imagery taken by a normal bands like green, blue, and yellow, normal satellite. Whereas
Mm.
This one is a SAR imagery. So
mm,
you can see how the things are much more clear in SAR as compared to an optical imagery.
mm,
We don't need to go into the mathematics of it. So, just like in our optical imagery, we studied there needs to be atmospheric correction, right?
mm,
Similarly, in SAR imagery, there is speckle because it is emitting uh, it's emitting its own energy that is being reflected and it comes back. So the objects in the environment around it also sometimes the for example, if this is the satellite and it is moving, so maybe this was your object of concern. So there is a reflection of it, but sometimes there is because of the environment. For example, though there you has to be a reflection of this area in some different manner, but there can be disturbances in the environment. For
mm,
example, if this area is not smooth, so it kind of reflected into many reflections. It's not a smooth surface.
mm,
So ideally, this happens most of the time that the surface is not smooth, like a head of a tree or things on earth. Even the road surface is not so smooth.
mm,
The so because of such reflections, the original reflection of this area will go only, but there are many micro reflections, micro backscatters. Sorry, the reflection word is for optical only. So there are many micro backscatters that that cause noise in the backscatter of the. For example, when we were concerned about this object only, when we are looking at the backscatter of this object, but there are things like this, and there may be a ray that is coming in this path and it feels like it is coming from this only.
mm,
So that backscatter creates kind of a error. So that is called as noise.
mm,
So there is a way, and in when we do SAR processing, so there are ways to remove noise. So like
okay.
in optical, there used to be sunlight correction, atmospheric correction. So in this
Mm,
case, we have the noise.
mm, okay.
So the quality of your SAR image depends on. So because the signal that was coming, the, the backscatter is also called as signal. So signal to noise ratio. If the noise is high and your signal is less, that means
Mm,
your image is not good. So there is a term called as signal to noise ratio.
mm.
Also, the SAR band, it works, the sensor has the capability for it to work in different polarizations. Horizontal polarization, vertical polarization, horizontal vertical polarization. What this means is when the sensor releases a signal that the energy. So
Mm,
if this is going like this, if you think of a z axis also, this as Z axis, this is X, this is Y.
mm,
If there is a Z axis, so this one is going in X and Y,
mm,
right? So
mm,
what if it went into, if it goes in X and Z?
mm. Okay. So it's
So
like
there,
minus.
yeah. So there are, do you have a mathematical background, right? In
Mm,
12th?
yeah.
Yeah. So there are different polarizations, but this is like when you do analysis, it's just for your understanding that uh, the SAR imagery is
Mm,
based on also like for a single area, you can get three type of images and do
mm,
different kind of analysis. So that is depending on your sensor, what polarization are you getting your image on. So sometimes some sensors also work with like they have the capability to uh, capture the image in all three polarizations.
okay.
Yeah.
Mm. So these are all, we need to get this data by paying, right? It is not freely available for usage.
Some satellites provided for free, like Sentinel.
Mm,
Sentinel
okay.
provided for free. So it depends on their signal strength. Uh, like German Terrasar, it is paid. You need to get it by paying.
Mm,
But in
mm,
Sentinel, you can get it for free. The the signal strength in Terrasar is so good that it produces a really very high resolution imagery.
mm,
Whereas in Sentinel, it is not, I would say nothing as compared to Terrasar.
mm, mm.
Yeah. So there are, when a satellite orbits around Earth, there are two kind of mechanisms how they work. Why is it not changing? Push, boom, and whisk. Boom. So always a satellite, there is two ways that it captures data on Earth.
Mm,
So have you know this we used to for dusting, right? We move
correct.
it like this.
Mm, mm,
So
correct.
yeah. So if the satellite it 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 records it like this, like just below its nose, and it
Mm,
records the area like this.
okay. Mm,
So that is called as whisk broom scanner.
uh,
So and in case uh, if it is like the satellite is here and I'm sorry, yeah, and it kind of dusts or care like how do you say capture the area away from
the
the
whole time
satellite.
at a single time.
Yeah, like at the satellite at below it, it will not capture. It will capture it in like a away
Inclination.
position.
Okay.
So this is the two ways that the satellite captures. So, but
Mm,
for in particularly in case of SAR, So SAR is particularly side-looking push broom. So in a SAR satellite, it will never capture what is below it. So,
mm,
like, just to remember this, the thing is in whisk broom, it captures what is just that 90 degrees to it also. So,
mm,
this is the satellite it is capturing. It is moving like this. Whereas, if this is the satellite, it will not capture what is below it. It will capture in the forward direction,
okay.
right? So, similarly in SAR, this is the satellite. It is not capturing here. It will
Mm,
always send the signal
inclination.
like this.
Okay. Slant. Mm,
Yeah. So this is the satellite and the set angle that which it throws the signal. So this angle is called as look angle.
mm,
So the rest part is kind of advanced, but
mm,
there are some satellites like ALOS is a very important SAR satellite. So you can see it's a combination of three remote sensing satellites.
mm,
So there are three satellites working together to capture the data.
mhm,
So there is one Pulsar. Sorry, these are the three only. One is called Prism, one is called Evnir, one is called Pulsar. So
mm,
mainly that you will come across is this one,
mm,
Elos Pulsar. So this is used to create digital elevation models. So you'll come across this one a lot.
mm,
Then you have the Terrasar from the German Space Agency. So you can also have the uh, just a tandem exit. So this is one of the example, ice
mm,
monitoring. So you can
okay.
see how we can differentiate, okay, ice is so like you can highly distinct it from the area nearby.
Mm,
You can see in SAR, you could map the snow
mm,
marine application. That is to, for example, if you want to, if you are your ocean is in uh, it's at a boundary of two countries. Like, for example, the ocean between India and Sri Lanka. So,
okay.
if India has to do surveillance that
Mm,
how many ships are there and if our ships are not crossing to Sri Lankan or something like that. So,
okay.
or at any number, at any point of time, we just want to know number of ships in the sea. So
Mm,
we can do ship detection using SAR.
mm,
So this is one of the application that like in the beaches you have seen there is wave, but if there are very high ocean waves that can be also detected using SAR because there is a difference of elevation. SAR works on the principle of elevation. It can differentiate the elevation.
mhm,
So if, for example, this is in between an ocean, there is an oil spill.
okay.
This is from a tanker. So it has tracked like how the oil has spilled, and
Mm,
then they will send services here to look for it. So, for example, you want to do this at a night time. You can't use the normal imagery. So
mm,
at that time, you can use SAR to detect the oil spills.
Okay, just want to understand. SAR is a band, right? That were the yesterday we were discussing the same SAR we are discussing right now, so right?
SAR is like the satellites based on microwave radar.
Okay, that aperture. Uh,
What it means is SAR means is uh, satellite based on these bands are called SAR.
mm,
Like if a drone has this, I won't call it SAR. It is specifically for satellites only.
mm,
Satellites having these bands are called SAR.
mm. Okay.
Yeah. So
Okay, then let's say an example. We are sending an satellite to just capture the street map, that like open street map. So that will be having the visible for our naked eyes, the visible roads and these things. So this satellite does not comes under the SAR, correct?
no, 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 no. But yeah, that will not come under SAR.
Okay.
So flood monitoring, SAR is very, very useful for urban flood monitoring. Like if you live in a city and you
Mm,
want to see the extent of flooding,
mm,
so SAR is very helpful. So this is use case like they used SAR in these countries when this happened. So this is one example. NVSAT SAR was used to detect flood, to detect volcano, like the extent of volcano once it
mm,
happened. So, for example, if this blue thing, this was the original river and it got flooded it to this zone. So it
mm,
can be, this is the SAR imagery, it can be viewed in it. So this is basically the SAR imagery only. They changed the color of the extent to blue. So
mm,
this would have been like black. So
mm.
you can see like this is the river, but the flood went till this extent.
Okay.
Earthquakes, there is this one thing that is uh, if there is a landslide, earthquake, there is movement of the ground.
Mm,
Then using the data of timelines, like maybe today the satellite went from there and recorded its SAR imagery. And
mm,
tonight the earthquake happened or landslide happened. And
mm,
tomorrow again when the satellite came, it
mm,
took a SAR imagery. Using two imagery, there are some physical and mathematical operations that we do that we are able to understand the earthquakes, landslides,
mm,
that how the ground was moving, like how the I have the old image, I have the new image, and using some mathematical operations, I can evaluate the ground, the way in which the ground has moved after the earthquake.
mm, mm,
So, for example, here it shows in the red area, the earthquake was the most high. In yellow area, it was less, and then in this yellow, it was much lesser. Subsidence measurement, for example, uh, if, if there may be a highway or
mm.
you can call it, uh, sometimes
Mountain.
sometimes the land goes down because of some reasons.
Mm,
For example, if you are in a plateau, or you must have seen that in you must have read in news or somewhere that a crater or a round hole appeared in the roads.
Correct. Yeah. Yeah.
Yeah, yeah. So
Correct.
if you do constant checking of your highways using SAR,
Mm,
you can predict, okay, my road is getting in down, there is some depression happening in my road, like it is going lower. So uh, you can kind of prevent maybe from that big hole to happen. You can understand, okay, something is wrong with the ground. So, or for example, one very good use case of this in India is, uh,
mm,
so you mined coal and you told the government that I just mined uh, like I just mined only this much reserve, and the
mm,
government would send check from the SAR image before and the SAR image now, and they will compare and they will get how much the land has gone below. So they will
mm,
say, we see that the land has gone below 3 meters. According
mm,
to this, you have used up this reserve, but you are giving us a wrong value that you have just used up this reserve. So it is highly used in mining applications. Like the most widely used application of SAR I know is in mining and this particular use case, that is the subsidence mapping.
okay. Like how much they have taken so far and
Yeah.
okay.
For example, if some company was given a project to mine here in a small plot and they were allowed, so based on uh, the government know like how much reserve would 1 feet of ground have.
Okay.
So
Mm,
if the person took out 6 feet and
mm,
when he has to submit a report to the government, so
mm,
maybe for every feet he has 3,000 uh, as the unit of what he extracted. So 6 into 3,000 will be 18,000 that he has extracted. But what if
mm,
goes to government and says, I was just able to recover 14,000 and I have just done 5 feet. So
mm,
government using this or the private institution can use this to find
mm,
out how much he has actually uh, taken out, 6 feet or
mm,
5 feet. And
mm.
so this is a very widespread application of it.
Okay. What is this mapping half of please? Wide area pro
So, like, uh, how to say, have you heard like the Himalayas are rising 1 centimeter
mm,
each year?
yeah, yeah, I have heard about it.
In a similar manner, there are things like you must have heard Mumbai is going down.
Mm-hmm. I mean the sea rise.
Uh, yeah,
Okay.
the sea is rising, but also the land is also subsidizing. Uh,
Okay.
Not just the
Okay.
sea is rising, but on our planet, but it is like very, very minute, very minute.
Mm, mm,
For example, 0.0001 centimeter this year.
okay. Okay.
So that can also be mapped.
Ah,
Yeah.
okay. Mm,
So you see here, there is positive as well as negative. So what the positive represents is like here I can see positive in a large. So there must have been a large scale city project, like new buildings come up.
mm,
So that is not subsidence, that is elevation.
mm.
So you
Okay.
see that there is this rest of it is quite advanced. Now we will move to the LiDAR.
Okay.
So what is happening is the what LiDAR principle is. So LiDAR's principle is this. For example, this is a sensor and it is placed, maybe it is placed on a aeroplane. It can be a aeroplane. It can be a drone. It can be a satellite,
mm,
or it can be, so this is in the sky, this, or if this is the ground, you can even place it on a tripod on a ground, the LiDAR.
mm,
Okay. So LiDAR is called light detection and ranging.
mm,
So maybe I explain myself only. So what is happening? For example, there is a wall here, and you're standing here with this LiDAR sensor. So what this do is, and have you been, did you use like laser in your like childhood?
yes.
Yes.
Laser
So,
lights.
yeah. So it is something similar. What it does is it sends a beam, not exactly beam, but it sends, yeah, light detection. Yeah, it's a beam. So it sends a beam of light. So
Mm,
this light goes straight and it doesn't go in any other direction. It reflects back in this direction only.
mm,
So you know the speed of light,
mm,
you know the time it took from here to here and to come back.
mm,
So you know the speed, you know the time.
mm,
So that will give you this value, distance, but it will give you double because it went and came back, right?
mm,
So in LiDAR, speed of light into the time taken by 2 is the distance.
mm,
It is kind of it is very similar to the laser that we used in our childhood. So you can place it on ground, you can place it on anywhere, right?
mm. Yeah.
So there are some wavelengths in which LiDAR works. So LiDAR is itself not a wavelength. It is kind of a mechanism. So that mechanism uses, like I said, you
Mm,
must have seen laser of green light and red light, right?
yeah.
So instead of those green and red, I'm gonna use this wavelength, this wavelength, this wavelength, this wavelength, and this wavelength.
Mm,
So I'll call it a LiDAR.
okay.
Okay. So using different wavelength, it has different applications.
Mm, mm,
So if I'm using in case of ultraviolet, I can use it for atmospheric studies. If I'm using a visible green, which is bathymetric LiDAR, this is the one you wanted to, it is, I can explain to you. This one, we talked about something similar last time. For example, this is an ocean.
mm,
This is the ocean surface,
okay.
right? Maybe you can have a drone here.
Mm,
Maybe you can have a ship here.
mm,
And if it is mounted with the bathymetric LiDAR, a LiDAR with this wavelength,
okay.
it can do. what you asked last time. It could measure the distance,
Mm-hmm.
right? And
Okay.
because, for example, if you send like if your sensor is big and you send many, for example, I'll give you an example like this. Uh, yeah, I have this mountain like this,
Mm,
and this is the ground. And you are standing here with a sensor. So, for example, uh, there are mechanisms inside it, there are lenses inside it that can make the beam straight to understand. So, that is the part of the physics. But for you to understand now, for example, how it works is because of those lenses, it will, for example, consider the lens, the sensor to be this big, consider it to be this big. This is the science that we have been able to make it in such a small way, but consider the lens to be this big, right?
mm, okay.
So when each part of it, from every part of it, we throw a beam, it goes here, gets reflected, goes here, gets reflected.
Mm,
So this will form an image here that would look like this.
mm,
Got the point?
yeah.
So basically, it took the distance. That is, for example, this was 30 meters, the above one was 35, maybe this is 40. So it stored a data and we can use it, or that we can create an image of how it looked. So
Mm,
similarly, if it was from a satellite and
mm,
there are buildings here,
mm.
so it can take images from everywhere, right?
Vertically.
Yeah, vertically. But I'm just saying like the sensor behaves as it if it is like it will take image, and because the sensor inside there are lenses and all, even if like it takes like this, it will make it straight inside.
Mm, mm,
But the principle is this that you should think like it went straight, and
okay.
because of this, it is able to see its height.
Mm,
So, for example, you have a tree. There are leaves in it, right? Many leaves.
mm,
Now your sensor throws thousands of laser beams.
okay.
Now, some of them reflect back.
Mm,
Like if there is a point here, it reflects back from here. And if because at this point the leaf was high and there is gap between the leaves, right?
mm,
So it passes and maybe hits another leaf and then it
mm,
comes back. So it will kind of reflect at each passage
mm,
at this point, until wherever it was able to go.
mm,
For example, it passed through,
okay.
right? So
Mm,
it will hit the ground, it will go back.
mm,
So you will get kind of a 3D information of the ground.
Yeah.
So for example, this is the LiDAR sensor over a maybe mounted over a car.
Okay.
Just give me one moment, please. So you can see that LiDAR sensor wherever hit and got back, it created a point.
Mm.
And for that point, if we click, we can see its distance from the sensor.
Okay.
And using this data, we can kind of create a 3D model of the area, right?
Mm. Through the tools like any specialized tool,
To
any like how to make a 3D image.
yeah, yeah, you can do it in ArcGIS, QGIS itself.
Mm.
So, for example, I will show you. There was we did one in our masters. So we had a drone which was LiDAR mounted.
Mm.
So we took the LiDAR data of the area, but since this is false color, this is like random color.
Okay.
We gave like uh, this color is based on the distance itself. This is or you can choose actually colors based on your understanding. Like some people base it on distance, some people base it on the actual how the thing actually looks on ground. Some people may add a color sensor to the sensor which will catch the color and then that 3D LiDAR point they will give that color from the sensor, right?
Mm.
So for example, it's not working. Yeah, takes a little. So this is using a drone.
Mm.
This is a patch on the ground, right?
Mm.
Hello.
Yeah, I can hear.
Yeah. So this is what we uh, based on a LiDAR drone, we captured this and
Okay. Oh,
so you can visualize like
in the
each
3D. Ah,
yeah,
okay.
like
Okay.
so it gives it to us in points. There are
Ah.
round points, right?
Mm.
So these were trees around a river. Mm. For example, this is like a tree grown not so vertical, it's a oblique tree. So you can see
mm,
now. So this gives us a 3D idea of the surface, the area. So
mm.
this is actually how LiDAR works. So I have extracted the color from Sentinel image and imposed the color on my LiDAR data. So now it looks what it actually looks like on ground. So the trees
Mm,
look green and everything. But
mm.
uh, when was captured in default, it looked like this. So
Oh,
it was
okay,
based on elevation.
okay.
So higher the elevation, the more red it is. As you
Mm,
go lower, it goes yellow, and as you go
okay.
lower, it goes blue. So this now for this area, I know how
Mhm.
much part is at a particular elevation or above it. So this
Okay.
kind of LiDAR is also very useful in
Mm,
biomass, like to understand trees, to understand ecology. So this is very highly useful in that case.
okay.
Right. Just a moment. Sure. So you you can see the areas. So basically now you understand what is the principle of LiDAR, right?
Mm, mm,
And we have an understanding of uh, the wavelengths that it works.
mm.
So the one we used in this one, it was this one, near infrared,
Okay.
among these two. But what if my aim was to, now there is this river that is going here, right? What if my aim was to see the depth of the riverbed?
Uh-huh.
Then I would have used uh, this one, green one.
Mm, mm. So with the same leader, it has a how to change the configuration or
So,
while.
for example, if you have the drone, in that drone, it has the option to switch to different wavelength.
Oh, okay.
Yeah. So these two are very commonly available in drones, but you have to they are commonly available. But for example, if your normal drone is 400 euros, so they will cost like 600 to 700 euros with
Mm,
if including these two bands, LiDAR bands.
okay.
Yeah. So okay. Now one of our other aim was now since we have covered this part, right? The LiDAR
Mm,
one.
mm, yeah.
Now we know most about satellite data. We have understood it in details here, right?
Mm,
But what is the difference between satellite and drone data? So, for example, the very first thing is satellite has a very big coverage, right?
mm, yes.
Drone has a very small coverage.
Mm,
Secondly, drone will be very high resolution.
okay.
Satellite, like drone is very near the ground, so it will take very high resolution images as compared to satellite.
Mm,
For example, you can take in a drone a resolution of 5 centimeter.
mm,
That a pixel on the ground is of the size of 5 centimeter.
okay.
Your hand is bigger than 5 centimeter, right?
Yes.
But I don't think so with any satellite that is possible,
Oh, okay.
right? I can't take a
Sure.
satellite image in which I can view your hand,
Mm,
right?
correct.
So maybe in future we come up with such technologies, but the resolution is different.
Mm,
Secondly, and also, uh, so these were the drone. So whenever you have to take a drone imagery,
mm,
you need to give it a flight plan. You have to give your drone a plan.
mm.
So this is like we have talked about shape files, right?
Yes.
So you create a shape file or like this, or there are also when you have a drone, there is option to also make it in the drone controller itself. You can create it this with your hand. So
Mm,
you have to create like a drone plan. So my drone will fly from this. It will go from here. It will go from here. It
mm,
will go and capture the imagery.
mm,
So it will capture till the end here,
mm.
right? But
Yeah.
for satellite, there are orbits.
Okay. Mm,
Yeah. So, for example, uh, based on the three bands, the red, green, blue, I take this, but the region is just so small, whereas for a satellite, it would have been the like satellites have like big size of images, right? Like the
mm,
extent would have been like 15 kilometers to 20 kilometers.
mm,
So we have LiDAR here. We also have satellites with LiDAR.
mm,
So you need to see if those satellites are the data is freely available or not. So the one thing is the data that is produced here, the 3D data that is produced here, in drone terms, it is called as point cloud data.
okay.
So if someone gives you a drone project
Mm,
and they will talk to you and you will have an understanding and tell you at the end of the day we want a image in true color, we want a image in maybe four or five different bands, red, green, blue,
mm,
and also they may ask from you point cloud data.
mm. Okay.
So this data is the point cloud data.
Okay. So, true color means the exact colors of the objects which has.
No, just like a satellite, your drone works with different bands, right? Blue color, green color.
Mm, mm, mm,
So it captures all this and combines into a true color image. So like the way a satellite does. So
mm,
the basic principle is same here. If a satellite has blue band, your
mm,
drone also has a blue band,
mm,
right? Now, one very important concept is overlapping.
mm,
Now, uh, do you know why with your eyes you are able to see things in 3D?
mm.
Do you know?
3D.
Why,
Uh,
when you are looking around, just wherever you're sitting right now, just look
mm,
around and you can see and you can tell, okay, that thing is that far away and that thing is near to me. With your eyes, you
mm,
are able to uh, perceive that which thing is far from you, which thing is near to you. Do you know
mm,
why?
mm. No, maybe. The concept of 3D is XYZ.
No,
Uh,
no, 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 no. Just place two things, one thing far from you and one thing
okay.
near to you. But with your
Yeah.
eyes, you can see and your brain can understand that one of the
Mm.
thing is near to
Far
you
and near. Mm.
and one of the thing is far to you.
Correct.
Yeah. So
Yes.
why that happens is if your eye would not have been curved,
Okay.
if it would like the basic reason why God has given you two eyes. For
Uh-huh.
example, if your eyes were not curved and they were straight, flat,
Mm. Okay.
if you close your one eye, you are still able to perceive things far or
The
near,
same way.
but not with that accuracy. But with two eyes, you are able to see more accurately, right?
Mm.
So, but if your eyes were flat, you
Mm.
would not have been able to perceive the depth of the object.
Oh, okay.
So that principle,
Mm.
when I have for example, this is your house on ground.
Mm.
Now, for example, if I show you any image,
Mhm.
you look at this one. Can you tell me which thing is near, which is far? Nothing. As a
Yeah.
human, you know this is river going, that is, you can tell it is more deeper. But
Mm.
just because you know, otherwise, if you look at the image, can you tell me?
No.
Okay, if I go into this region, can you tell me if this is at elevation or this is at elevation?
No.
Now
I
you
can't.
don't, your mind doesn't know. So
Mm.
now, now, for example, on ground, I have maybe this is a building.
Mm.
So when a satellite, maybe it took image of this much area from here to here,
Okay.
right? So when it came next here, when the satellite came here, I will maybe say this much area, like, right?
Mm.
And when this satellite came here, so for the mechanism of satellites to get more analysis out of it, we have to place it such. Now the next image that it takes has to have some overlap with the old
Mm.
image.
Correct.
So there is an overlap here.
Mm.
Now, why this overlap is needed? Just place yourself here and
Mm.
think these are your two eyes.
Mm.
So these are your two eyes because they are flat. The concept when you have two eyes, now this area that was common in both your eyes, you
Mm.
will able you will be able to perceive the depth of it.
Okay.
LiDAR was something else. It was moving like this. In
Mm.
LiDAR, we could directly make a 3D. But if it's a green band, blue band, we have
Mm.
reflectances and they
Mm.
move like this. They are not like in LiDAR, they are going 90-degree and coming back. They are
Mm.
moving in in different angles. So in that case, when we have two images being overlapped, that overlap part can be perceived in 3D.
Mm.
This is a very important concept. Do you understand it?
Yeah. Yeah.
So is it new for you or you knew something like it before?
No. The overlapping I have here,
Mm.
but I'm not. I'm not aware about how to uh, work on that, remove that overlapping after taking the drone image.
So there is something that a term will you will be coming across that is called as orthorectified image.
Okay.
So that means is placing two images.
Mm,
For example, I gave you this image and I gave you an image from here and I gave
mm,
you an image from here. So
mm,
placing it in such a manner that they come overlap each other here
mm,
and then you wear a 3D glasses. If instead of here you sit here, if I give you just me let me explain you in a very other way. So I captured one image here. That image is from here to here.
mm,
Now I'll capture another image too, which is from here to here.
mm,
And now if I give this is a table, just like a chair and table, this is a table, and I
mm,
give you these two images.
mm,
So these two images. Now there is a special kind of microscope, or you can say you can also wear it on your eyes. So
okay.
when you keep it on your eyes and you
Mm,
place with the given overlap, the actual overlap it is here, and you place instead of this, you place it like this.
okay.
When you see this with that microscope or with
Mm,
that lens, you will see this
mm.
in 3D, how it is
Ah,
actually on ground.
okay.
These two images were 2D, right?
Mm,
But
yeah.
when you place them in overlap, that the
Mm,
satellite has how it has captured it. When you place them in overlap, so now it is this part is called as a orthorectified image,
okay.
and
Mm,
you are able to look at it at as 3D.
okay. Mm, mm, okay.
So this is how satellites
Mm,
make digital elevation model.
okay.
So if there is a satellite,
Mm,
it made a digital elevation model of that area.
okay.
So it was using this principle.
Okay. So actually, it capturing the image like 90-degree, but it is the concept of overlapping. It gives the final result as 3D.
Yeah.
Okay. So this
So
happens in the satellite itself, or else we need to process it after taking the picture.
no, someone processes it here on the ground. Otherwise, it will be very stressful for the satellite to have a onboard computer.
Okay.
The satellite will just give you the bands. You do
Mm,
it.
mm, 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 mm.
Okay.
Okay. Okay.
And similarly, in a similar way,
Mm,
when your drone captures images, so for example, when my
mm,
drone was moving here, it captured this much image,
mm,
right?
mm. Okay.
So when it is going to capture next image, there is an
Mm,
option which you enter. It asks you to before flying that what percent do you want overlapping.
mm,
So the next image that it will capture and the previous image it captured has an overlapping.
mm,
Got it?
mhm. Okay.
Also with the side imagery it will take with this imagery it also has an overlapping here.
Mm,
So with the same concept I just explained, this overlapping area will be used to create 3D elevation of that area.
mhm. Okay.
Got it?
Yeah.
So Uh, you can create a digital elevation model from a satellite imagery, from a drone imagery. If your
mm,
drone is LiDAR based,
mm,
for example, I give you two drones. One is with the normal bands, normal red, green, blue band, normal bands. So
okay,
with the concept of overlapping, you can create a digital elevation model here.
okay,
So
mm,
otherwise, if I give you a LiDAR, in LiDAR, you see that it it gives you something like this.
mm,
So you can also convert this also to a digital elevation model.
mm,
This is a model itself, right?
mm,
You can
yeah,
convert it also to a proper digital elevation model. It will use something, for example, in between these 2 points, there is no elevation. So it will look for the next point and create a elevation. So it will give a continuous elevation model.
mm,
So that is the digital elevation model.
okay,
Now, for example, this is a person who has taken a satellite imagery of some area and he tries to do a drone imagery of this area. So he has to prepare a flight plan. So this
okay,
dots represent the places where the drone will take an image,
mm,
right?
mm,
Uh, So if you zoom out of an imagery, any satellite imagery you have, but
yeah,
at this scale, what that means is 1 centimeter is uh, showing 2 lakh centimeters, like 1 centimeter on this scale, this imagery,
mm,
1 centimeter here represent two lakh centimeters actually on ground.
okay,
You understand that
mm,
part?
mm, mm, yes, yes,
Yeah. So this is called the scale. For example, I say, okay, in the desktop you're viewing, this is 1 centimeter
mm,
as according to your computer screen.
okay,
According, but actually on ground, it is 2 lakh centimeters. If you go there in that area, if you check, this is 2 lakh centimeters.
okay,
This. So this
mm,
is the scale of the image.
okay,
If it is a map and something right, this is written, it is the scale of the map.
mm, mm,
Now, when you have a imagery when you are very zoomed out, you can't see the pixels here. It will look to you very high resolution, but as you zoom it, it will split into boxes. And we have seen that before, right?
mm,
So when you zoom in, these are the boxes, right?
pixels, okay,
So this is images using three different satellites. This is in
mm,
ISRI, this is Landsat, this is MassGIS. So now this is satellite imageries. Now see
okay,
from drone how clear it is, right?
mm,
From drone it is so clearly visible because you are capable with the drone to take it on 1 to 1000 scale. And see if you zoom it at a scale of that 1 centimeter represents 300 centimeter.
uh,
So in the Landsat imagery, you can't see anything. Sorry, in ArcGIS imagery. Whereas in
mm,
MassGIS, you are little bit able to understand, but see the clarity in drone imagery, right?
mm,
So left is drone imagery, right is mass aerial imagery. Just look at the difference.
Okay.
I can't even make out with this imagery what this is, but here I can just think it
Mm.
is kind of stairs or something.
Okay.
So again, examples with different scales. In Landsat, you have like this. In drone, you can take a good imagery.
Mm.
So, as this person also says,
Very.
cost is a very important aspect as I felt I should be discussed. For you, Landsat imagery is free, right?
Mm-hmm.
If you
Yeah.
need a high resolution imagery, we
Mm.
need to deploy a drone and it will take some money.
Mm-hmm.
So, or maybe if you want a NV high resolution ArcGIS imagery, so that is like 700 euros per year. So you have to pay for high resolution imageries, or so that is depending on your budget, the kind of resolution you can take.
Okay.
So there is something called as LULC that I will uh, so like we did some analysis at that time. For example, this is a imagery of 2018, this one, and this is an imagery of 2023. So in
Mm.
2018, you can see the biomass, the trees. There were not so much trees here. The
Mm.
vegetation was not so good.
Mm-hmm.
Like even the trees, existing trees were not so big or something. Whereas
Okay.
in 2023, you can see the biomass increased.
Mm.
Similarly, in NDVI, similarly in NDVI, you can see the crop health here. You can compare for regions. For
Mm.
example, the crop health here has fallen, whereas in, or you can just take some analysis for this patch. In
Mm.
2020, there was no, it feels like there was no crop here. In 2023, there is some crops here.
Mm.
So, so what we did was, this is this river,
Okay.
and along that river, it is a very small river. So
Mm-hmm.
we took a area of that river. This is our field area, study area.
Mm.
We made a flight plan along it. So this was all possible with the help of drone. So this was the type of a. So
True.
we used
Mm.
DJI Phantom 4. So it is a
Okay.
multi-spectral drone. Like it has all the bands. Uh,
Mm.
these are the bands included: RGB and IR.
So this data was back in 2018, is it?
23.
Okay. Okay.
Yeah. So and then uh, it was also like the our drone has also this sensor with it, L1 LiDAR. So it is like it is we get some sensors. We take out the multispectral one and fit in the LiDAR one.
Mm.
So this is our trajectory of the drone.
Okay.
Then our aim was to find out these things.
Mm.
So we did biomass estimation, like um, just a moment. No. So we kind of did the biomass estimation, the places where biomass has increased.
Okay.
This
So
water
after
quality. Huh?
okay, so you need to be have the geography background to analyze after this capturing this data, right? So the geography students or background of the people only can able to do this.
I
It's
don't know
just a tool for you.
geography.
Drone is a tool.
No, no, it's not true. Like many of my classmates were not even from geography. Most of them were from computer science only.
Okay. So this project you have done in your master's, correct?
Yeah.
Okay.
So, okay, so this is NDVI visualization. So like there was crop like vegetation cover here, but
Mm.
it is decreased now. You can see the river has bloomed much.
Mm.
Similarly, there is something called as LULC. So,
Mm.
for example, here you can just make the inference like this area is now built up, something they have built up here. It was
Mm.
not there before.
Mm.
So, this is what we used the from the overlapping of the image, we got the depth of the no, sorry. We used the green lidar to understand the base of the river
Mm. Mm.
that was passing through.
Okay. This is the inside of the river.
Yeah, this thing. So we
Mm.
flown a lidar drone from here to here, and
Mm.
it gave us the base of the river. Yeah, that's that's it. So
Okay.
I think we are done for today. And do you have any doubts for today's class?
No.
No. But I would suggest you to read more about LiDAR, like this history, and I'll give you the link of it.
Okay.
So as I said, it works on the principle of laser, right? I
Mm-hmm.
explained this to you, right?
Yes.
Mm, I'll share with you. Please copy it from here. So on Monday, as I said, in morning I won't be available. I'll
Mm.
let you know the time probably at 5 or 5. Are you available at 5 on Monday?
Yes, I'm available.
Yeah. So we'll do the session at 5 in the evening, okay?
Sure. Okay.
Okay, take care and have a good day.
Yeah. You too. Bye bye.
Yeah,
Happy day.
yeah, you too.